computer. Okay, so last time we have talked about confidence intervals. We have reviewed what we have seen before the spring break, and we also started to summarize it in a little table. I hope you guys still remember it. So today we are trying to focus on the interpretation of confidence interval. So the confidence interval is like this. If you guys still remember, we have a X bar, right? Plus or minus a margin of error. So generally speaking, confidence interval for any parameter is your statistic plus or minus the margin of error. And the margin of error is calculated by using the critical value. Another way of saying critical value is called multiplier. That's the t value or z value that we have talked about times the standard error, which is our, sigma divided by square root of n or s divided by square root of n. So in this lecture, we are trying to focus on the interpretation of confidence interval. So how often do we capture the parameter? Most of the time, we will capture the parameter. So this is happening when remember this graph we see here? When your margin of error captures the true parameter. So when the confidence interval will include the true parameter, that is when your margin of error captures the true parameter. Sometimes it will not. If you guys still remember the graph we have seen, we constructed 100 confidence intervals, and 5 of them didn't capture the true parameter. That is usually happening when your value of statistic is extreme, which means it's far from the parameter. Now, take a look at the example here. I will give you a few seconds to read the question. So let's do A first. Use this information to find a 90% confidence interval for the true mean about the students at MSSU spent on textbook this term. So the parameter of interest is the true mean amount students spent on textbook, right? So the parameter of interest is the mu. Now we are trying to construct a 90% confidence interval. So for A, so she randomly selected 25 students at the university and found that they had spent an average of 372 with a standard deviation of 172. So in this case, we don't know the population standard deviation. We only know the sample standard deviation, 172. So what we are going to do is we are going to use the T formula for the confidence interval, right? So our sample size n is 25, and we can assume like the average amount of money students spend on textbook is at least symmetric. So the formula we are going to use is x bar plus or minus t alpha over 2 and minus 1 s divided by square root of n. So we are going to plug in formulas, plug in the numbers here. It's 372 plus or minus. We are going to leave our t value here. It's s 172 divided by square root of n25. We have talked about how to find this t value, right? So I'm going to draw the graph here. So it's a 90% confidence interval. So the value here would be 5% here and 5% here. So the degrees of freedom is n minus 1, which is 24. So using the table, all the StatCrunch, we are able to find out the t statistic, not statistic, the t critical value is 1.711. Then we could have our confidence interval to be 313.18 and 430.82. Okay, so I'm going to unmute you guys to see if you have any questions so far. Let me stop share. Unmute all. Okay. So.
Can you go back to the screen, please?
Okay. Back to the screen. Any questions so far?
How did you get 1.711?
That's what we have talked about before using StatCrunch, all the table, right? If you want, I can show you how to use StatCrunch. Let's try to do.
Could you show us how to do the table?
Okay. Let's do both. Okay. The reason why I'm using StatCrunch more is because we are not going to have a closed book exam. So our final exam will very likely to be a take-home exam. So you don't really need to know if you are not really comfortable with the table. You could use whatever you want. So let's do StatCrunch first, then we will do the table. Are you guys able to see the StatCrunch? Probably not.
No.
I need to share this. Are you guys able to see the StatCrunch now?
Yeah.
Yeah.
you are able to unmute you guys. I unmute you guys out. So if you go to Stat, Calculator, T, Distribution. So what is the degrees of freedom in this question? Say it, I can't see the chat.
24.
Okay, so it's 24. Now we are trying to look for alpha is 10%. So alpha over 2 is 5%. So we are trying to look for the value where the property x greater than point, that value is 0.05. So let's compute it. It's about 1.711 approximately. Does that crunch make sense to you guys? Does that crunch make sense to you guys?
Yeah, I understand.
Okay. Okay. So the next thing is the table. So let's take a look at the T table, which is posted on Moodle. Are you guys able to see the T table here?
Yes.
Okay. So
Yes.
we are trying to look for a T table with degrees of freedom equals 24. Now the area under the curve to the right of it is 0.05, right? So if you guys still remember the T table, the first column is the degrees of freedom. The first line is the area to the right of the curve. So degrees of freedom equals 24, and the area to the right of the curve equals 0.05 is 1.711, as what we have seen in StatCrunch. Is this good?
Yeah.
Okay. Any other questions about what we have done? So let me share this. The 0.05 is, this is 90% confidence interval. So C is 90%. The area under the curve to the on the two extremes will be 10%. So it's symmetric. Each of them will be 5%. Any other questions? Are we good here? Okay. So I'm now going to take you guys to the breakout room. I want you guys to take a look at BCD and try to, answer it, try to interpret. I'm going to mute you guys. I want you guys to take a look at BCD and try to interpret it on your own. Imagine that your grandma is calling you. For example, you guys are doing this online teaching, right? Your grandma never heard about it. She doesn't know what's going on, how things are doing. So she's making a phone call and checking with you. Hey, how's your online teaching doing? What did you talk about this morning? And you guys said, oh, grandma, we are talking about the stupid confidence interval. And she was like, what's confidence interval? So try to write a sentence to interpret the confidence interval and the confidence level that we have talked about. Then probably your great grandma, what I'm trying to say is I'm trying to have you explain it to someone that doesn't understand SAS. So try to explain it in a plain English that, you know, people could understand it. Maybe your grandpa, if your grandma knows more SAS. So try to answer B, C, and D and discuss it with your group members. So I'm going to create a breakout room and make you guys discuss it with your classmates. I will give you 2 to 3 minutes, and when I end the breakout room, it will give you like a notice. You know, they were saying the breakout room will end in 1 minute. So that's when you should wrap up your discussion and come back. Okay, so okay, please accept my invitation. So for those of you who are still here, do you have a problem going into the breakout room again? Because if you do have an invitation, please go ahead to talk with your classmates, right? Okay, I'm going to end it.
Is this guided notes 10?
What?
Is this
No,
guided?
this is 9 part 2.
Yes.
Help me. Okay, thanks.
Mm-hmm.
Okay, guys. How would you, explain this to your grandma or grandpa who doesn't know anything about statistics? How would you explain it? For B, interpreting the confidence interval. How would you interpret it? Anyone volunteer for B?
I would say that according to the sample taken, 90% of students would fall between $313 and $430 for how much they pay for textbooks.
How many of you guys agree with him? You know, you remember that yes or no button? Okay, let's see.
I thought it was more like we can be 90% confident that the mean was between our upper and lower bound.
Yes, you are correct. So the answer for the first question from the first student, thank you so much. That is a kind of a typical misinterpretation that students always make. So the confidence interval is not about individual students. It's not about saying 90% of the students will be in this interval. It's about the samples that it's about the procedures of the samples that we are talking about. So the second interpretation is a good one. So let me write it. This is so for B, again, please remember what I've just said. There is a typical misinterpretation. It's not about the individuals of the sample. It is about the procedure. So what we should tell our grandma, grandpa is we believe that the true mean spent on textbook by students at this MSSU is between the lower bound and the upper bound. Okay, then grandma is, you know, a wise lady. She asks questions. So she's like, okay, kid, so how confident are you about your belief? How confident are you about your belief?
Would you say 90%?
Yes, 90%. So we believe, and how confident are we about our belief? It's about we are 90% confident that the true mean blah, 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 blah. Okay, so that is for part B. This is a sentence to interpret the confidence interval in the context of the problem. So grandma, again, as I've mentioned, is a wise lady who asks questions. So she's like, what do you mean by you are 90% confident? How do you know you are 90% confident, right? So that is our answer to our part C. Interpret the confidence level. What does it mean by 90% confident? Anyone try to explain to grandma? Any volunteer?
Isn't it essentially that if we were to do this multiple times, then 90% of the time, the confidence interval would contain the true mean?
Yes, that's true. That is, if this researcher, she repeatedly repeated taking samples of 25 students from her population then 90% of the resulting confidence intervals would contain the true mean spent on textbook by the student. So this is B is how you would interpret a confidence interval, and C is how you would interpret a confidence level in plain English. Now here is a note here. This is not for your grandma. This is for you who have know some statistic. So note. I think I've talked about this before the spring break when we first introduced the concept of confidence interval, that this population parameter mu is fixed. This is not changing. And that is another very typical misinterpretation as well. So the confidence interval changes from sample to sample. If you guys still remember the graph that we have seen, right? For the 100 different times we repeat the procedure, we have different confidence intervals. So the mu doesn't change. It is the confidence interval that does change from sample to sample. And now moving to the next page, the probability that a confidence interval calculated using the formula that we have used, this x bar plus or minus t s or square root of n will enclose mu is approximately . Any questions about B and C? Okay.
I have a question about when you use the z-score versus the t-score.
Yes, we actually summarized it in a little table last class. If you still, do you still remember that we did a little table?
Yeah, I have that in front of me, but I'm a
Okay.
little confused because
Why?
it says if n is small, and then if it's normal, and if the variance is unknown, then you use the t-distribution. But if we're given the standard deviation, can't we find the variance?
This, why is this moving like this? Give me, so sigma is population standard deviation. In this case, I don't know why my handwriting messed up here, but in this case, we don't know the population standard deviation. What we do know is the sample standard deviation, S, right?
Yes. Oh, all right. That makes sense.
So this S is this standard deviation is the standard deviation she got from her sample. So we are using the t-score.
Okay. Yeah, that makes sense.
Okay. Any other questions? Okay, so if we have no questions, and I don't know why my handwriting is like this now, then let's take a look at the last one, D. can you conclude that the mean cost on textbook is different from 400? What would you say? Yes or no? Let me see if I can see that. Could you guys do this yes or no? For part D, do you say yes or no? Okay.
I think we can say no.
Yes. So the correct answer is a no, because you see this confidence interval here, right? This 400 falls into this confidence interval. This confidence interval is our 90% confidence interval, right? So it is very likely that the true mean is in this interval. So we cannot conclude that the mean is different from 400 because 400 falls into the confidence interval that we calculated. So for part D, this is a no because 400 is contained in the confidence interval. So our sample does not provide enough evidence that the mean spent on textbook by the MSSU students is different from 400. This is the end of this question. Anything that you are not certain about? Anything more you want to discuss?
So for part D, if we were kind of to generalize what the question asked, if we're talking about any value within the confidence interval, the answer to D would be no. But if the question said, you know, can we conclude that the mean is different than 500 or something, some value outside of this interval, we could say, yes, we can conclude this is true with the same 90% confidence. Is that kind of what this question is saying? Or?
Yes, exactly. That's what this question is trying to say. If the value falls within the confidence interval, which means it is quite likely that your true mean is 400, right? So then we can't conclude it's different from 400. If it is a value that is, say, in your example, 500, that's outside it, then we can't conclude yes. So to answer your question, you are exactly correct. Any other thing we want to discuss? Okay.
I have a
Okay.
question.
Go ahead.
Is there a difference between true mean and mean that's talking about in D? Like A and D, there's true mean, and then D just talks about mean.
No, there's no difference. I'm trying to emphasize the mean is the population mean. That's why I'm saying it's the true mean.
Okay.
Okay, so let's move on. And I'm trying to summarize it a little bit here about some important points about confidence. And we have talked about it through, you know, all the previous questions and concepts, but I'm just trying to summarize it here a little bit. So this confidence is in the procedure, right? It is not like I've mentioned, a big misinterpretation. It's not about individual samples. So this is, so you may see this is a little bit, redundant for some of you who quite understand the concept, but this is just I'm trying to summarize it here and reinstate it for those of you who are still not quite clear about what we are what we are talking about. So this is about procedure. A particular interval either does or doesn't contain the parameter. This is the thing that we mentioned on the first day when we introduced confidence interval, right? The probability that your mu is less than, for example, is 0.9. This is absolutely wrong because a particular interval either contain or doesn't contain the parameter. So the probability will either be 1 or 0. So this is definitely wrong. What is correct is if, okay, where am I? If we create confidence interval over and over some percentage of them will contain the parameter. The second thing I want to talk about is this confidence interval is arbitrary. So it is, I want you to create a 90% confidence interval. I want you to create an 80% confidence interval. This confidence level that someone set up is arbitrary. So remember, we have used an example. The example I used before the spring break is we want to know the proportion of people in North Carolina who's in favor of tax raise. Do you guys remember that example? And you guys are asking good questions. What is this tax raise for, right? So then I'm saying, okay, I'm giving you a 100% confidence interval. So the proportion of people in North Carolina who's in favor of tax raise is from 0 to 1. So it doesn't give you any useful information, right? So a higher confidence interval, a higher confidence level doesn't really speak to anything about the quality of the data. So this is just chosen by the person who's creating the interval. And high confidence doesn't speak to the quality of the data procedure. So the most commonly used confidence interval is 95%. Other commonly used could be 90% confidence or 99% confidence. Again, it doesn't speak to the quality of the data. It actually is a trade-off between the usability and the confidence. Because a larger level of confidence produces a larger margin of error. So we have a larger confidence, but the larger the confidence interval, the less useful it is. In that example we have talked about, the 100% confidence interval is for the proportion of people in North Carolina who's in favor of tax raise is from 0 to 1. You know, your confidence level is pretty big, but the usefulness is none, right? So for some confidence interval, your confidence is smaller, but it is more useful, right? Say, if I'm giving you a confidence interval from 0.2 to 0.4, then you kind of have a better understanding about the answer you are looking for, right? Another thing is, it doesn't matter about the sample size as well. So a large sample size does produce a smaller margin of error. We have talked about that on the page when we introduced the Z confidence interval, but it doesn't influence the confidence. So if you're trying to create, say, a 95% confidence interval, for the first time, you collect samples of sample size equals 25. Then based on the formula we have talked about, you are creating a 95% confidence interval. Even though you increase your sample size, say you are increasing your sample size to 1,000, you follow the same formula that we have talked about to calculate the confidence interval. You are still getting a 95% confidence interval. It's just this time you are having a smaller margin of error, so you are having a narrower confidence interval. You are getting a more precise estimate of your true population parameter, but it is still a 95% confident. So the sample size doesn't influence the confidence. The confidence interval is about the parameter, not about the other samples or individuals. So, like I've mentioned, the typical misinterpretation said 90% of individuals, say individual values, they are not in the interval. It's not like that. It is if we take another sample its statistic may not into this interval, may not fall into this interval, right? Because each time you collect a sample, you are having a different confidence interval. So its statistic may not fall in the interval. What we are trying to say is we believe the true parameter, the parameter is in the interval most of the time. The last thing is the margin of error only accounts for the random sampling variability. It doesn't address the bias in the sample. Any questions about what have been talked about in here? It's pretty much same thing that we have talked about, but I'm just trying to summarize it so that you get a clearer picture. Any questions about any of these? Okay, so if you have no questions, Please go ahead to take a look at this additional example 1 and try to see how you would answer those questions. I'm going to do that breakout room again. By the way, how are you guys doing in your breakout room? Do you guys actually discuss and talk to each other there?
Yeah.
Yeah, okay.
Yeah.
So let's do this breakout room and you guys take a look at the next additional example. I will give you 4 minutes or so. For those of you who are still here, you can discuss with each other as well. Okay, I'm going to end this breakout room.
Oh, okay. Well, they're main session.
Yes, we are back.
Oh yeah. Woo.
How's your breakout room doing?
How's what?
I'm saying, how does your guys' breakdown working out?
Good.
Oh, we got 2 of them done. Heck yeah.
Okay,
I didn't even, I'm gonna be honest, didn't know what we were doing.
okay, then let's just talk about the first 3. I will give you some other time for D then. For A, what was the sample average age at which babies begin to crawl? What do you think? What did you guys get?
I got 30.5.
How did you get that?
I took the average of the confidence interval bounds.
That's correct. So remember when we calculate the confidence interval, right? It is your X bar plus or minus your margin of error. So your lower bound is 29.2, your upper bound is 31.8. So your X bar should be the average of it over 2. This is 30.5 weeks. Then what is the margin of error for this interval?
1.3, I think.
Yes. So here, this X bar is 30.5. We just calculated. So the margin of error is the difference between the 30.5 and 31.8, right? So it's you could calculate it as this divided by 2, which is 1.3. Now let's talk about C. C is what we have just talked about, how to interpret your confidence interval and confidence level. So does anyone want to fill in the blanks here?
We are 90% confident that the true value of the average age at which babies begin to crawl is between 29.2 and 31.8.
Good. Then how would you fill in the blanks for the interpretation of confidence level? Does anyone want to try that? That is, if we take many samples of the same size, then about 90% of the resulting confidence intervals would contain the true average age at which babies begin to crawl. Okay, so then is part D. I heard you guys haven't finished it yet, so I'm going to give you a few more minutes about this. Remember, those are all incorrect. It has been told that below are the 3 incorrect interpretations for the confidence interval. Then how would you explain why they are incorrect? So I'm going to put you guys into that breakout room again. We'll give you 2 to 3 more minutes. Okay, we are back to the main room now. Does anyone want to explain, for example, number 1? Why is number 1 wrong?
Our confidence interval, the mean ages that a baby will start to crawl. So it doesn't talk about individual babies. Like
That's correct. Like I've mentioned, this is the confidence interval is talking about the procedure. It's not talking about individuals. So the confidence interval are not about individual values. What we should say is we believe we are 90% confident, and then the average age at which babies begin to crawl is 29.2 to 31.8. It's not about individual babies. Okay, good. What about question number 2? Why is 2 wrong?
So what my group said was that even though when we're talking about, confidence intervals, we are talking about like the probability for, if you took a bunch of samples and you looked at a bunch of confidence intervals, the problem with this statement, number 2, is that every sample that we take, we have to calculate, we use the same procedure, but we calculate probably a slightly different confidence interval. So the bounds would not be 29.2 and 31.8 for every single sample. This statement would be correct if we just said 90% of all samples, will have confidence intervals that cover the mean, but because we added in these particular numbers for this specific sample that the scientists took, that makes it incorrect.
That's very correct. That's exact what I was trying to say. So this number that we calculated is just, based on one sample that we have collected. It has nothing to do with all the other samples. So what he just said is exactly what I want to say. So a confidence interval is based on one single sample. It doesn't indicate where the means of other samples will be. Okay, what about the last one? Why is the last one wrong? Why is the last one wrong?
Is it because the actual mean of the population doesn't change?
Yes, that's correct. So what's this one is talking about? It is this one is actually saying, okay, the true mean is in between the probability of the true mean in between 29.2 and 31.8 is 90%, right? And as I've mentioned, this is wrong because the true mean mu is fixed. So the population mean age is not changing. It is 90% of the time that the confidence interval will contain the population mean value. Remember when I first talked about it, it was before the spring break, and I was using the average height of the students in our class as the example. I was saying if I collect one sample and I calculate the confidence interval, say from 5.8 to 6.2, it doesn't mean the population true mean your true average height is in the probability of that in between 5.8 and 6.2 is 90%. That true population mean doesn't change. Okay, so this is pretty much what I tried to talk about today. There are two things that I want to say before you guys leave. First, I was also planning to do a discussion boards because we started 10 minutes late, so we don't have time for that. It's available on Moodle now. You should have no problem doing it. Let me share this with you. It's here, this discussion board 2, which is due by next Wednesday. After the due date, I will post the correct solution on Moodle. Again, this is all about your participation, not about your performance. So you should have no problem answering it wrong. So another thing is we are still going to meet on Saturday, and this is going to be the same link, the same ID that I just posted on discussion forum. I may post it again. That is not the DB2. You just take a look at this. It's linked to this file. It doesn't matter. You should be able to get access to it. So it's going to be the same link on Saturday. And any further questions? Okay, if you have no questions,
It's
thank you so much for being here.
it's not
What?
letting me see the
Same time, yes.
Hello?
What was your question?
it's not letting me see the link for the discussion too. Like actually in the discussion board.
Okay.
It says it's this activity is currently hidden.
Yeah, when I
Can
click
you
it,
refresh your page? I mean, it doesn't hurt me to make it available.
It's showing up for me now.
okay, it works now, yeah.
It's good now
Yeah, it's good now.
because I was I made it
Yes.
available, you know, during your breakout room time. So maybe you need to just refresh it.
Yep, it's good now.
Okay. Good. And by the way, I'm holding office hours on Zoom as well. It's just a different link. Nobody was here on Monday. So if you have any questions, feel free to stop by. Okay?
Cool, thank you.
Sure.
Have a
Sure.
nice day.
You too.
Dr. Sodi,
What?
I have a last question. This someone was talking about the YouTube video. Did you find out that one?
I don't know. I mean, it was a girl who recommended last time. Is the girl here today? I don't know. I mean, I didn't know what she's referring to. So I posted on a general discussion forum. I hope she sees it and will reply to me.
She said something about like if you type in like statistics for engineers on YouTube, someone comes up, but I don't know who the exact person she's talking about is. I was looking for it yesterday too, but I couldn't find exactly who she was talking about.
Yeah, I did like the same thing, and I got like a bunch of different, the videos. some of them are like a piece by piece is good, but some of them are like a, just
Absolute trash. Yeah.
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 I don't know that either. I mean, but it's good that you guys can tell what is good, what is trash, right?
Yeah. Yeah.
Yeah, but like it's a wastage of time, like if you got a bunch of things like screening.
Yeah. I don't think she's here today, or she's not. Oh, she's not in class anymore. I think she left. The girl who actually told us about it, she's gone.
But
She
I
was
mean,
here.
I asked this question at the beginning of the class
Yeah.
when we were all here. If she heard it, she probably will reply to my post in the
Yeah.
discussion forum.
All right. Well, thank you.
Sure, thank you.
Have a nice day.
You too.